All right, today we are continuing section 6.1. We are going to be talking about two new rules having to deal with exponents: power of a power and power of a product. So those are the two rules we are going to talk about today. On Friday, we talked about product of powers, which was a little bit different when we multiplied two terms together. When we multiplied two terms together with the same base, what did we do with the exponents? We added them. Okay, so today's rules will be a little bit different. If we take -2 cubed, what happens? What are we doing? What do we get? Times -2. Okay, we've got -2 multiplied to itself 3 times. Because the negative was inside the parentheses, it's stuck to the 2. When we multiply those together, what do we get? -8. All right, on number 2, this one's a little bit different. It does go back to some of the rules we did talk about or you had to answer a question about on one of your worksheets. If we take -b to the 5th power, do you think the answer will come out positive or negative?
No, negative.
Negative, because we have an odd power. So if we were to write this out, we could write all 5 of these negative b's out. A negative times a negative makes a positive, but then we have 1 left over. So a positive times a positive times a negative means our answer is definitely negative b to the, don't make it hard, 5th power. Questions about warm-ups 1 or 2? Need more time? On we go. Oh, thought we had one more warm-up.
We
do.
Find the missing exponent.
Yeah, that one's just not up on the board. So
It's 3.
7 question mark times, what is it, 7 to the 5th?
Equals 7 to the 8th.
Okay, so some people have already said the missing one is 3, and I would agree with that. So in order to get the 8, we would have to add these exponents. So the missing exponent would have to be 3, because 3 plus 5 gives us 8. Questions, concerns before we get to
What are you supposed to write something there?
the title?
Oh.
The title of the section is Power of a Power and Power of a Product. Okay, so let's get into those rules. First one, power of a power. So let's start with for all positive integers m and n. If we take, in parentheses, a to the m power, and then raise those parentheses to the n power. So we have something with an exponent, and we're raising it to another exponent. We would have a to the m times n power. So in our notes, to find a power of a power, what did we do with those exponents? You multiply the exponents. Okay, that's a little bit different than power of a product. So if we have a product of something like AB, all of it raised to the m power, that's going to be the same as a to the m power times b to the m power. So in the notes, to find the power of a product, you find the power of each factor and then multiply. Okay, so everything inside of the parentheses gets that exponent. We can extend this power of a product rule. It doesn't matter how many factors you have in your parentheses. We could have put the whole alphabet in there, and then every single part, A, B, C, D, everything in the parentheses gets that exponent of n. Anybody need more time on this slide? All right, then we just need to start practicing using these rules. On example 1, we have m cubed in parentheses to the 4th power. So this is an example of a power raised to another power. You have an exponent with another exponent outside. So we multiply the exponents, we get m to the 12th power. Okay, on number 2, I would simplify from the inside out. So what that means is if we have a negative b raised to the 4th power, if you have a negative raised to an even power, the answer is going to come out to be what?
Negative.
Right? Even power. Well, if we're not sure, let's write it out. If you're ever unsure, you can expand this out. So inside those parentheses, we would have 4 negative b's. A negative times a negative is always a positive, and a positive times a positive is a positive. So we really end up having b to the 4th raised to the 5th power. We don't really need the brackets anymore. And if we're raising the 4th power to the 5th power, what do we do with those exponents? Multiply them, and we get b to the 20th power. Questions about 1 or 2? Okay, on example 3, we have a product 2 times y, all raised to the 4th power. So that exponent outside the parentheses belongs to every factor inside. So 2 gets raised to the 4th power, and y gets raised to the 4th power. If you need to put the multiplication dot in between them, you can. You don't necessarily have to. Every factor gets that exponent. What part of this could be simplified more? 2 to the 4th equals 16. So we really have 16y to the 4th. Questions about examples 1, 2, or 3? Okay, we'll keep moving. Example 4 gets a little more interesting. There's nothing to simplify inside of the parentheses, but we do have an exponent outside those parentheses. So that exponent outside belongs to every single factor inside. How many factors are inside this time?
4 or 3.
3 of them. What are the factors?
4 squared.
Hold on. What are the factors inside the parentheses?
4ab.
I almost agree. 4 is one of those factors. It gets squared. A cubed is a factor. It gets squared. B squared is a factor, and it gets squared. Notice that if it already had an exponent, I put it in parentheses. Do we have questions about what I've done so far? Okay, 4 squared is easy to simplify. 4 squared is 16. Now, on both A and B, we have an exponent raised to another exponent. For a power to a power, what do we do with the exponents? Multiply. So A to the B to the 4th. Power to a power, we multiply. So 3 times 2 gave us 6. 2 times 2 gave us 4. Questions about example 4? Okay, on example 5, we follow our order of operations. There's nothing to do within the parentheses, so we move on to our exponents. You have to simplify the exponents before you deal with multiplying the 3 and the 2, or the x and the x. So make sure you're always keeping your order of operations in mind. What exponent does the 3 end up getting?
2.
The x cubed gets what exponent? The 2 gets what exponent? And the x gets a 4. Okay, so anything inside the parentheses gets the exponent that's right outside. Let's go through left to right and simplify some more. 3 squared is 9. On this first x, we have a power raised to a power. So what do we do with the 3 and the 2? Multiply. 3 times 2 is, okay, 2 to the 4th is 16. And then x to the 4th is as simple as it gets. If you want to put little multiplication dots in between all of these, you can. If you want to use parentheses, you can. But we have to understand that we're still multiplying all of these things. So the 9 is going to get multiplied by 16. 9 times 16 is 144. X to the 6 gets multiplied to x to the 4th. When we multiply the same base, what do we do with the exponents? We add them, so it's x to the 10th power. You have to keep in mind what rule applies for what part of the problem you're doing. So this problem actually had all of the rules we've talked about so far, including from Friday. Questions about example 5? Okay, we'll move on. I'm going to take away a couple of these at a time so I've got a little bit of room. On example 6, there are 2 different ways you could approach this problem. You could substitute right away, which is usually what I recommend, and then go through your order of operations. Or you could simplify the expression with your rules of exponents and then substitute in. Generally, I would recommend substituting right away. Remember, when you substitute, replace your variable with an extra set of parentheses and then plug in your number. So what number is getting plugged into that spot? A 2. They said x is equal to 2. Okay, 3. Well, never mind. Back up. I'll ask you first. What should we do next by our order of operations? our parentheses. So what's happening inside the parentheses?
Times 2.
We're being multiplied. 3 times 2 is 6. And then we're cubing 6,
216.
which gives us 216. Now, you could have given your exponent to everything inside first. You could have done this 3 cubed times x cubed. 3 cubed is 27 times your x is a 2. And 2 cubed is 8. Okay, and 27 times 8 would also be 216. It does not matter to me which way you do it, as long as you show me your work. Okay, so one way we plugged in right away. The other way we simplified our exponent first. Doesn't make a difference. You should get the same answer either way you do it. Questions about either method? Okay, again on example 7, I would recommend substituting first. Meaning I put a blank where my variable was. Into this blank, what number am I putting? A -4. Okay, by our order of operations, we should start inside the parentheses. So a -4 is really what?
Positive 4.
A +4, and +4 squared is 16. If you were to do this the other way, if you square a negative, it is going to end up being positive y squared. And then in there we would plug in a -4. -4 times -4 is still positive 16. So either way you do it, substitute first or simplify first, you get the same answer. Questions on 6 or 7 before they disappear and we bring back 8 and 9? Going once? Twice? All right. Let's bring back 8 and 9. On this one, there's really no simplifying to do before time. There's really just one way of doing it. I'm going to rewrite it up above when I plug in. So I am raising 3 to what power?
The second.
2.
Second power. Times I'm taking 2 to the third power. 3 squared
9.
is 9. 2 cubed. 9 times 8, 72. Questions about number 8? Okay, number 9 is again one that you could do 2 different ways. I prefer substituting first. So this time I've got 2 sets of parentheses inside my original parentheses. What am I plugging into my first blank? A 2 for x. My second blank, -4 for y. Based on my order of operations, what should I do? What's in the parentheses?
What are we at?
2 times -4.
2 times -4, which is?
6, -16.
No,
-8.
-8.
Where are we?
And then we square that. -8 squared is,
-6.
Maybe.
careful, Dominic,
64 plus 64.
a positive 64. Negative times a negative is a positive.
I'll put it in parentheses.
Okay, the other way you could do this, I'll change colors, is you could give the exponent to both the x and the y. So x squared times y squared. And then plug in 2 squared times -4 squared. 2 squared is 4. Negative 4 squared is 16. You multiply them, you still get a positive 64. Again, it doesn't matter to me which way you do it, as long as you're showing me your work. What questions do we have? Nothing? Okay, I want to do one more problem together. Let me. So we'll call this, what was that? That was 8 and 9. We can call this one 10. Okay, let's see how good our skills really are. Take a minute and see what you get for this, and we will talk about it momentarily. Anybody want to volunteer what their answer is? And we'll get a list of some potential answers. Jasmine?
32 x to the 100, y to 100, z to 50.
Okay. Anybody else have a potential answer? I'm not saying whether these are right or wrong. These are some ideas. Dominic?
100x, y 25, z 50.
Hold on.
C.
Say that a little slower. 100.
X, and then y 25, and then z 50.
Okay. Anybody? Is that how I have it written? Is that what you had?
Yeah.
Okay. Any other possibilities? I'm not sure I agree with either of these completely. Lydia?
I think I did mine wrong. I'm gonna do y 25, z 50.
X to the 20th. Y to the 25th. Z to the 50th. I think we're getting closer. Yes?
X the same as y to the 25th, z to the 50th.
Okay. I think we have some good pieces. Anybody have anything different? Okay, so let's go through this one piece at a time. For our first set of parentheses, everything in there, the 2, the x squared, and the y, all of those are getting what exponent?
5.
The 5th. So 2 to the 5th power, x squared. If it already has an exponent, I would recommend using parentheses. X squared to the 5th power,
10.
and y to the 5th power.
5.
It's multiplied by everything in the second set of parentheses gets what exponent?
Same.
The 10th. So x to the 10th, y squared to the 10th, z to the 5th to the 10th. All right? Now let's go through one piece at a time and simplify. 2 to the 5th should be the easy part. What's 2 to the 5th? 32. Then we move on. We have x squared to the 5th power. If you raise a power to another power, what do you do with the exponents?
Multiply.
Multiply them. 2 times 5 is
10.
10. Y to the 5th, there's nothing to change there right now. Times, moving on, x to the 10th, there's nothing to change there right now.
Y to the 20th.
Y, is it y to the 20th?
Yeah. And z to the 50th.
Y, is it y to the 20th?
Oh, why is it y to the 20th?
Mm-hmm.
Because 2 times 10.
Okay, we gotta multiply our exponents. 2 times 10 is 20.
Yeah.
Same thing with z to the
50th.
50th. So it looks like everybody got the z part of this, right? Everybody agreed there.
I still got the same answer.
All right, now when we move on, to this next part of multiplying, the 32 is technically getting multiplied by
1.
a 1, so I agree that we begin with a 32. We have to multiply x to the 10th to x to the 10th.
10 times 10 is 100.
Are we raising a power to another power?
No.
No, we're multiplying two things with the same base.
So you add them.
So we add the exponents, so we have x to the
20th.
same thing with y.
1 to the 25th, z to the 5th.
Good.
Oh, wow. Okay.
So, should have told us beforehand.
Well, I don't
So it looks like if we mixed our last couple answers, if we had that 32 instead of an 80, that one would have been good. Or if we'd had a 20 instead of a 17 here, that would have been good. So most people had at least parts of it correct that volunteered answers. Do we have questions about any of those steps?